Hi, and welcome back to our flipped classroom for chemistry. Today we are talking about some of the trends in atomic properties and how those are periodic or how they are repeating as we look at the periodic table. So, what are we going to do today? So, today we are going to define three different atomic properties. Those are ionization energy, electronegativity, and atomic radius. And we are going to learn how to use the periodic table to predict those trends and identify those trends. So just a quick reminder about the periodic table. So we remember that periods are what we call those horizontal rows on the table, and groups or families are what we call the vertical columns of the table. And we know that as we move across the table, that there are certain trends that are going to repeat as we go across, and there are certain things that are going to change as we go up and down. So the first property that we are going to define is atomic radius. And atomic radius we define as half the distance between the nuclei in a covalently bonded diatomic model, which seems like an awkward way to define a radius. But if you think about the structure of an atom, that electron cloud is very difficult to define where it begins and ends. And so we define the radius as half the distance between two atoms. So as we go across a period, this seems very, very counterintuitive. Our radius is actually going to decrease. And that's because as we go across a period, we're adding more protons to the nucleus, and we're not increasing the number of layers. And so those protons are going to pull ever harder and harder on those electrons, and they're going to pull the electrons in, and that's actually going to cause the radius to decrease, even though we're adding more stuff. Each successive atom, as we go across a period, each successive element has more stuff, but it gets smaller. Now remember, that's within a period. We have increased what we call effective nuclear charge. That has to do with the number of protons, and no more shielding. As we go down the periodic table, though, our radius is going to increase, because as we go down, each row on the periodic table adds an energy level or a shell. So we can think of this kind of like the layers of an onion, that as we go down the group, we're adding more and more layers. And so our elements are getting larger and larger. Because we're adding more layers, we're decreasing the number of protons that those outer electrons can see. All right, so we can just look at a few pieces of data here. So this is a table of atomic radii, and you can see that as we go across a period, that these are getting smaller and smaller. Now you can see there's a big difference here between the metals and the non-metals. We see a big jump there, but in general, as we go across the period, those radii are decreasing. And this is that shown graphically. You can see this is within a period that it's going down. Now we jump up to the next period and they get larger, and then it starts to decrease again. So I'm not gonna ask you to compare between two groups as you go down, but just within one group as you go down, or within one period as you go across. So if we were to look at the periodic table as a whole, as we go across from left to right, the atomic radius is going to decrease. And as we go down, the atomic radius is going to increase. So our next property that we're going to define is ionization energy. And this is defined as the energy that's required to remove an electron from an atom. So we're talking about how much energy it takes to pull an electron off. As you might imagine, as we go across a period, because that effective nuclear charge, because the number of protons in the nucleus is increasing, the electrons are closer and they're seeing a higher charge, so they're harder to remove. So as radius decreases, ionization energy increases. As the number of protons increases, ionization energy also increases. As we go down a group, so now we're going down within one column, it's going to decrease because those electrons are farther away from the nucleus, so they're easier to remove. This is just like when we hold two magnets close together, we can feel a strong attraction between them. But when we hold them farther apart, we really don't see much of an attraction between them at all. And that's the same principle that we're applying here. Those electrons that are farther away from the nucleus have a weaker attraction to the nucleus and are therefore easier to remove. Okay, as we go across the table then, from left to right, the ionization energy is going to increase. As we go from top to bottom, ionization energy is going to decrease. All right, one more property to define, and that is electronegativity. And this term electronegativity means it is a measurement of the ability of an atom to draw electrons towards itself within a covalent bond. So this really is how strongly an atom can attract electrons. And as you might expect, that comes back to the radius as well as the charge. So as we go across a period and the radius is decreasing, those electrons are getting closer and closer to that bonding atom's nucleus, it's going to become stronger and stronger at pulling electrons towards itself. So electronegativity is going to increase across a period. As we go down within a group, again, radius is increasing. So that means our electron affinity is going to decrease because those electrons are farther from the bonding atom's nucleus. So here's actually a periodic table of those electronegativities. You'll notice that we leave out the noble gases on this periodic table. And that's because when we talk about electronegativity, we're talking about the ability of an atom to draw electrons towards itself within a covalent bond. And since the noble gases don't generally form covalent bonds, we leave them out. And you'll notice here that fluorine is the most electronegative element on the periodic table. So as we approach fluorine, electronegativity increases. As we move away from fluorine, electronegativity decreases. So we see that same trend with electronegativity that we had with ionization energy. It increases as we go across the table. It decreases as we go down the table. All right, so the three periodic trends that we've talked about: atomic radius, ionization, and electronegativity. As we go across the table, atomic radius decreases, which then causes ionization energy and electronegativity to increase. As we go down within a group, atomic radius increases, which causes ionization energy and electronegativity to decrease. So that's it for today. As always, if you have any questions, please let me know. I look forward to seeing you in class.